Right, right. Very interesting. So, one of you is now a polysaccharide in a muscle molecule, and another one is an oligosaccharide, a shorter chain on a red blood cell. What then? That's a very interesting question. When the skeletal muscle cell needed energy to run up a flight of steps, it turned to the glycogen inside it, and to me, glucose, to provide this energy. Now, because energy from sunlight had been stored in me to make these chemical bonds, when the chemical bonds were broken, this same energy allowed for the creation of ATP, which the muscle cells could then use to power their muscle contractions. Interestingly, the muscle did not have enough oxygen to break this glucose down completely, and so I was simply broken in half to make two molecules of pyruvate. I was then converted to lactic acid, put into the blood, and then the liver put the lactic acid together again to make another molecule of glucose, which could then power more muscle contractions. And so I found that my end allowed the body to provide for its energy needs.
I guess I also provided for energy needs, but in a different way. When the red blood cell died, as they do, they only live about 120 days or so. After it died, I was recycled. The body likes to recycle all of its organic molecules. And me, glucose floating into the blood, I ended up being taken up by the liver. See, the liver at that time felt that because of the big plate of pasta that you had just eaten, that you had too much glucose in your body and you had to turn it into something else, like fat. And so the liver then took me and many other glucose molecules and then started changing us, taking our carbons and oxygens and hydrogens and converting them to glycerol and to fatty acids. And then these were later taken up by fat cells and are stored there as triglycerides for when you need energy later. So I guess I still am storing energy for the body's energy demands, but no longer in the form of glucose, but rather in the form of fat.
There you have it. Two very different life stories from two very different glucose molecules. Thank you, guests, for your time. You've been so very sweet.